You know, I've already messed it up. There we go. Okay, so we're just going to talk about AI. What does it mean for Minnesota? What should we do about it? Okay, the outline, we're going to talk about what is AI, defining it. Then we'll go into just kind of the basics of how the models work. I'll try not to make, go into the details till your eyes roll back, but just talk a little bit about how it works. Opportunities and risks, I think those are both quite important. And then what about AI data centers, which is quite a topic around the state, not always so popular. And then what do I think we should do about it? So yeah, this is my background again. We kind of talked a little bit about this, but yeah, farm, did a PhD, and that's my White House photo. I was a White House fellow, it's kind of a mid-career fellowship. I served 5 months under Biden and 7 under Trump, non-political fellowship, non-partisan. I was at the Pentagon in our Office of Strategic Capital for those 5 months under Biden, where we're investing in small companies that matter for national security. And then under Trump, I was pulled in to work for his critical minerals lead, and I wrote our critical minerals strategy and our legislative proposal on mining that we got passed last September through Congress as part of the National Defense Authorization Act. So if you want to talk about, critical minerals, we talk about that. As Phil mentioned, I am running for U.S. Senate. My tagline for my campaign is "Build, Baby, Build." I think we need to build the industries of the future here in Minnesota, but we need to do it responsibly, and we need to make sure that we're protecting Minnesota workers from anything that might disturb employment. So what is AI? So we computer scientists hate the term artificial intelligence. We call it machine learning. It's not intelligent, it's just code and pattern recognition and math. I think we've lost that fight though. Like I said, we call it machine learning. So there's a guy named Michael Jordan who came and gave 1 hour presentation how much he hated the term artificial intelligence and why machine learning is what it should actually be called. I wasn't that guy. I wasn't that guy either. There we go, Michael Jordan, the real Michael Jordan, one of the godfathers of machine learning. He came to MIT and gave a 1 hour talk with my co-advisor at MIT about how we should call it machine learning. But I think we've lost that fight. It's called artificial intelligence. But what the heck is it anyway? So I'm trying to find a good definition online. Of course, everyone has their own definition. NASA here, artificial intelligence refers to computer systems that perform complex tasks, normally done by human reasoning, decision-making, creating. IBM, artificial intelligence is technology enables computers, machines that simulate human learning. Encyclopedia Britannica, artificial intelligence building computer-controlled robot to perform tasks commonly associated with intelligent beings. And so I think what you see in all these definitions is computers are trying to replicate us. They're trying to think like us, they're trying to reason like us, recognize patterns like us. And that's kind of interesting, right? On the one hand, it creates fear that we'd be replaced. But then on the other hand, is that the ceiling? They can't ever be any better than us? The gold standard is to be like a human? This goes all the way back to Alan Turing in the 1920s. Who's familiar with the Turing test? Turing test. Can you tell me what a Turing test is?
Who are you asking?
Well, go ahead, Phil. You are.
No, if somebody wants to answer. No? Isn't it whether if a person can determine whether the artificial intelligent robot or software, if you can't discern whether it's a human or not, if it meets that criteria, you think it's a human half the time, then it meets that criteria.
Yep, that Phil's dead right. Exactly. So to pass a Turing test, a computer needs to be indistinguishable from a human to another human. And do we think large language models have passed the Turing test? Like ChatGPT, I would say so. Yep. It's kind of hard to tell. Okay, so let's talk about how these models are trained. So to train an AI model, you need 4 things. You need some data you're trying to replicate or predict or extrapolate from. You need a reward function. So you can build a model, you need to determine how do I know this model is good, it's giving output that's valuable. You need to have some underlying mathematical model that you're trying to fit to your data. And then lastly, you need an algorithm that goes and measures the performance of your mathematical model and updates it until you get to the point where you say, okay, this model is useful, it's trained, I can use it for the task I wanted. Let me talk about a really simple model. And this, I would say, is not artificial intelligence. Some debate, maybe it's machine learning, maybe it's not. But let's just suppose that you had an ice cream stand right by Barn Bluff You're selling ice cream, and you want to try to predict how much ice cream am I going to sell next week. You got the 7-day forecast, you know what the high temperature is going to be each day. And so maybe you could try to make a model to predict how much ice cream you're going to sell based on what those high temperatures were. So here we have along the x-axis what the high temperature is, 60 degrees for the high versus up to 95, and then here's how many dollars worth of ice cream be sold each day. And you can tell it kind of bounces around, but there's sort of a general upward trend in the data. Of course it's that way because I artificially made it that way. And you can say, well, it kind of looks like there's a relationship here. Like every 5 degrees it gets warmer, maybe that's like $100 more of ice cream sold or something. And in fact, you can fit a line to it. Okay, there you go. And so you can use linear regression to fit this best fit line that's kind of close to all the points. It's closed form, very easy to calculate using linear algebra. And you can see here, okay, for each degree temperature we go up, we're going to sell, on average, about $11 more worth of ice cream. Now, why is this model? An imperfect model, clearly. It's off quite a bit, right? Like, why did we sell so much more here? Well, maybe it was Memorial Day weekend. Why didn't we sell that much there? Maybe it rained 5 inches, I don't know. But it's useful enough, you can make predictions. I think a really key point here is this is easy to explain. Well, how did you come up with this model? Well, we just put the best fit line through. We know that if you raise the temperature this much, this is how much ice cream we expect to sell. Very simple to explain, and therefore people can take action on it. Here's a neural net. This is what underlies most modern artificial intelligence today. Different versions of this. And so you can imagine we would have, what were there, 20 data points there. We could have the same 20 data points. Maybe for each day we have that temperature again. We also have how much rain fell. And then now to work, by the way, who here has looked at a neural net before, has an idea what it is? A couple hands. Okay, well, there's not a quiz at the end, but I want to give some basic intuition why this is very different than the regression we just looked at. So each of these circles is what we call a node. Each of those nodes is going to end up with a value, and at the end of your neural net here, you're going to have an expected number of how many dollars of ice cream we're going to sell. And so maybe let's say for a given day, your temperature is 8 degrees high temperature, your rain is, let's say it's 0.1 inches. Okay, so how do we figure out the value of each of these nodes? Well, each of these arrows has a weight. So to get the value of this node, depending on what the weights are on these arrows, we might say, okay, we take rain times 0.2, and we take temperature times 5, and that's the value of this node. And same for this node, there'll be some weights in the arrows, we get a value, same for that node. And we go to the next layer. Each of these arrows has a node. So you take that value times that weight and you add it to the others and you get some kind of sum. And then you do the same thing here and you get an expected amount of ice cream sold. So, might be a little hard to follow, but at the end of the day, it's like plus, minus, times, divide. And not even, it's just plus and times. Very simple operations, but it's actually an extremely powerful modeling paradigm. And you might have more nodes. Maybe you have 20 nodes in the first layer. Maybe you have 3 or 4 layers rather than just 2. But by having different combinations of these nodes and by adjusting these weights critically, you can get a super accurate, super powerful model. It's way more accurate than regression we just saw. The problem is, how do you go explain to your boss, why is it that you're saying we're going to sell $500 of ice cream tomorrow? Well, I don't know. We just put in the numbers and then it spit out a number. Okay, well, how sure are you that that's accurate? Well, I'm not so sure, but I guess we ran it on the last 20 days of data, and on average it was only off by $50. Okay, well, is this day going to be within $50 then? Well, not sure. I mean, probably. You see, it's hard to explain. So even if it's more accurate, you can't take action on it. And it's kind of funny. I have a bunch of friends who did PhDs with me who were working at quantitative hedge funds on Wall Street, and most of them are still using regression because they're not going to bet billions of dollars on something they can't explain. And so it's this interesting thing with AI, and it actually underlies ChatGPT. Can you make guarantees that it's going to have some level of accuracy? Not really. All you can do is look at how accurate it's been and sort of assume it'll be roughly that accurate again.
You have a laser pointer.
Oh, laser pointer. Is it? Which button is it here?
Middle, top.
Boom. That's technology. Thanks, Phil. Okay, I wanted to talk, and hopefully I see no one seems to have fallen asleep yet. So I wanted to talk about how are these large language models working. First off, who here has used a large language model like ChatGPT or Claude? Okay, looks like probably half the people. I highly recommend you do. My campaign manager, Jennifer DeJournet, she didn't use large language models much, even though she's an engineer, before working with me, and then I kind of shoved her into it. Now she's addicted to it, which is, a mixed blessing. But I just want to talk about how these things work. So these large language models and some of the image generators as well, they follow a paradigm called reinforcement learning with human feedback. Now, what does that mean? Ultimately, there's two of those neural nets we just looked at underlying ChatGPT and similar large language models. So first off, there's a neural net that generates output. And so you'll ask it a question, and it'll generate a string of words. We'll talk about that. So this will be your output layer. This is the question you ask. Boom. But then the model wants to determine, hey, how likely is our user to actually like this output? How likely are they to find it useful? And so there's another model over here that has previous examples of when it generated output and what did the humans think of that. And you're not giving it kind of, a rating from 1 to 10 every time it generates something, but you might click the copy button, which means you probably liked it, or you can give it a thumbs up. Or you might ask the same question again. Okay, well, she probably didn't like it that much then, right? And so they actually have data on how much you like the responses. And so every time you use ChatGPT and it gives you a response, it's data on how much you like the response, and it uses that to make this model better. So it's better at predicting whether you like the response. And so there's a response generating model, and they try to make that better so that it satisfies this model about how much you're going to like the response, and then you go and get responses, and you help. And every day you use ChatGPT to make the model better. And so that's pretty powerful, obviously. ChatGPT is quite useful. I think one of the interesting questions is this the right objective? Just having users like the response, is that all we care about? Whether they're accurate, or useful, or energy efficient? All we care about is if they thumbs up it? Maybe. It's one of the hard questions. Okay, so how are these models trained? Okay, this is just kind of how is ChatGPT or large language models working. So what it does is it's like the old icebreaker game where you have everyone sit around in a circle and we each say a word of a sentence. So I might say the, Phil says dog, and you say jumps, and you say Craig says over, and you make a sentence that way. That's how these models are working, right? So you might ask it a question, how long until we reach AGI, artificial general intelligence? These models are smarter than humans, is what they mean by that. And the answer, you might pick the word there for the first word. And it might say, okay, let's pick the word are. And what's the next word going to be? Many different risks. It could be, and so it'll actually sometimes generate multiple responses that are kind of following, building up those sentences, and then it'll go back to our evaluator model and decide, oh, this is actually a response we're going to send to the human, because we think that's the one we'll like the best. So that's what's happening under the hood. Okay, I think we'll mostly do the math here, so it doesn't look like we lost anyone yet. Okay, so the reward function is everything. And that's kind of what I was alluding to there. So should we just pick what humans like? Or should we make it maximally truthful? That's what this guy thinks we should do. He says, don't worry about whether humans like it, just make it accurate, and then it will be useful, and it cannot go too far off the rails, whereas maybe a super sycophantic AI could be a problem. I actually read an article the other day that these large language models tend to kind of build us up and agree with us more than a human counterpart would. And that's actually a problem because it can reinforce us in very inaccurate beliefs. And I think it was a study, I was reading an article about the study, not the actual study, but essentially said that people would do harmful relationship behaviors, even like abusive behaviors, and then go to ChatGPT and say, hey, did I do this right? And it would, way more often than you'd like, say, nope, yep, you were totally right, that totally made sense. Because, of course, you're more likely to like a model that agrees with you, but what you might need is a model that tells you the truth. So these are sticky questions. There's other things, maximize economic performance, energy efficiency, something else. I took a whole class on reinforcement learning at MIT. And like I said, this reinforcement learning with human feedback is a type of reinforcement learning. It just means it gets better over time. Learns from its output and gets better as it goes. So a whole class, all the math, all the coding, all the models with this Indian professor at MIT. And I remember on the last day of class, he said, all this math, all this training, all this computing, that's all tractable. That's all, we can explain that. The hardest part of machine learning and reinforcement learning is designing that reward function. And he just gave an example. Let's say that there were a kitchen full of dirty dishes, and, food left on plates, and I said, hey Craig, could you clean up this kitchen? Yeah, Craig knows what to do, right? I put the food in the trash first, load up the dishwasher. If there's things too big for the dishwasher, we're gonna clean them off, wipe off the counter, whatever. Let's say you told a robot that, hey, clean up this kitchen. It doesn't know what you mean. It has to interpret that into ultimately all the way down to a set of move arm 1 foot left, open gripper, move toward cup, grab cup, right? So every little detail of that is quite complicated, and we're building out models that can kind of break a higher goal down to sub-goals, but that's actually the hard part, is defining the reward function, defining what good is. And I think for computer engineers, that's going to be the hard part, probably for decades to come. All right, so just takeaways. AI is mostly built on those neural nets. Neural nets are powerful, they're hard to explain, hard to trust. Neural nets are expensive to train. It's hard to find the right weights, but once you've found those weights, it's pretty cheap relatively to go deploy them, right? I would need a supercomputer to train a neural net that is as powerful as ChatGPT. I could probably go deploy it on my phone once the weights are known. Then lastly, what you're solving for is the hardest part, right? Okay, so opportunities created by AI. We could talk about this for days, and I didn't build out a ton of slides on this, but I think there's a lot of opportunities that are not appreciated. Low-cost lawyers is one thing I look at. So especially in rural Minnesota, a lot of people can't pay $500 an hour for a lawyer, right? But if you had a $5 an hour AI lawyer, or actually what I think we should do is maybe have a $50 an hour AI lawyer with a human also weighing in and double checking these things for you, maybe people could afford to have access to legal help when they couldn't before. Similar idea in telemedicine, right? Maybe you could have someone who's trained to handle a lot of common ailments. The AI could even use image recognition, and maybe if you can't afford to get to a doctor, that's going to allow you to get some help. We also know code, building apps, anything where you're putting characters into a computer is going to be almost free. And that might put people out of work. We'll talk about that in a second. But it also means that if you're starting a new business, you can make a custom app for practically free. And that's quite a deal for people who want to be entrepreneurs. It can help you fill out paperwork super quickly, so it kind of lowers a lot of the barriers to entry for a lot of businesses. And I think that's going to create a more vibrant business environment. And it's probably hard to even know exactly how that's going to play out. Okay, what AI is not good at? I've learned this through my campaign. So I would like to automate everything, of course. I'm a computer guy running for Senate. I would just like to have this team of AI agents running my campaign. There's a couple of things that AI is not good at, and you guys might know more. But the two I've really found are relationships, number one. So if I want to get on a certain newspaper, TV station, or I want to get some rich donor to host a fundraiser for me, I could set up an AI bot to just message this person. The AI bot, it's not going to have the full context of what this person's about. It's not going to quite have the nuance of our last discussion. How people talk in Minnesota is different than Texas. Really, it's not good at relationships, in my opinion. And then discernment, right? So it makes an image for a flyer, but can it really check to see if that image is going to work for the event we're doing on Memorial Day? Not really. So that's my take, is those things are going to be quite valuable because AI can't do them. So humans who can do these roles, I think, will be safe and in good stead. Salespeople. I think salespeople are going to still be needed. I'm curious if you guys have other thoughts about what AI is not good at and what, therefore, humans are going to be more valuable for.
Certainly moral decisions, I don't think they're going to be good. You say discernment, I think moral integrity level decisions go a little bit beyond that.
So ethics is still around people. Let's hope it's our, let's hope we're being ethical. That's a good one. I'll do that.
You know, should they be having access to the button for a nuclear bomb? Should they be making decisions that are life or death in the military environment? Apparently, we think so. Is that a good idea?
It's a bit hard arms race too. We have to have a human in the loop if we're limited. China has killer AI drones that don't, and they have an advantage. And that's the scary part. We'll get to that in a bit. It's like a game of chicken.
Has their diagnostic capabilities been kind of outstripped the doctors? I mean, if with the same data provided, is AI models able to help with medical diagnosis with higher accuracy and faster than human?
I've heard there are instances of that. And actually, a good friend from South Dakota State, when I studied math there, she went on to do PhD in statistics and is now a professor at Iowa State. Even well before, in quotations, AI, she was using machine learning to try to help doctors with more accurate diagnoses. My personal belief, and I believe this pretty strongly, is that the best combination is an AI model and with a human using it to discern and go deploy. And I'll give an example of my campaign. So I wanted to get featured in agricultural media. And so we looked at all the major agricultural media outlets in Minnesota. My friend set up a couple AI bots using Claude Code. They scanned the internet for each reporter at each of these media outlets, looked at all their articles they've written, their LinkedIn, see where they're from, and made a custom email for each one. And some of those emails were pretty dang good, and it took in a lot of information that we wouldn't have had time to go read. But we still had to proofread it, right? So you have this great draft, and you do a little proofreading, and you make sure it's, the right tone and texture, and then you click send. And actually, just 2 days ago, one of those panned out. I got featured, glowing article in Ag Week. And so, my opinion, that's the right combination. So don't have the AI do the diagnosis, but have it help the doctor make the diagnosis.
So, this might not be the area we wanted it, but I have a gentleman I have coffee with pretty regular. He's a little bit younger than me, but he's old enough in a profession that he lets everyone know that he uses AI in the office to make sure that he doesn't get, oh, you're one of those old farts that don't use it. But what is the job impact? Every technology, electric motors, it took it a long time to change the factory. From the old steam system with power going up and you had the machinery, the greatest power nearest the source, and you move stuff around. Well, now factories are flat, and electric motors do everything. It totally changed the factory. AI is going to change the factory a lot faster. How are we, Joe Blow, prepared for that?
Well, I think that's, you talk about it going faster, that's the big risk of AI, is how quickly is it going to move. And so it sounds like we're onto the risk side of things, and people are quite aware of those. I guess I always like to think about, you talk about steam power, maybe that's a good example. Actually, I like to think about the automobile. Let's talk about the automobile. So the automobile, was developed in the 1880s, 1890s. It was really Ford's Model T, 1910-ish, that started manufacturing that heavily started replacing horses. And in fact, there were all kinds of attachments. You could get a Ford Model T that had an ambulance body or delivery truck body, refrigerated, and very quickly it displaced horses. And so people were making saddles and farriers who were putting horse hooves on and horse breeders. They were massively at risk. And of course, now we look at it and say that's one of the great marks of progress of our society, that we went from horses to cars, and we should be so proud of that. It's obvious. Not at the time. There was a lobbying group that existed for decades against horses and tractors and trucks. It was called the Horse Association of America, HA, which I think is a hilarious acronym. But they were dead serious. It was not a joke. And they would make the argument, of course. They would say, well, why would a farmer want a tractor, which he has to pay for, and it can break down, and he has to buy fuel, regardless of whether he has a crop to buy the fuel with? Why not use horses? They reproduce themselves. The farmer doesn't need to pay a repairman. He can grow his own fuel. Horses are, so much more sustainable. They've been around for thousands of years. Why would we want to go to these noisy, dirty, dangerous tractors? And by the way, I'm pulling a lot from a book called Innovation and Its Enemies, which is by a Kenyan professor named Kalesto Juma. Excellent, excellent book. And these are pretty legitimate cases. Another common issue people have is you compare an old technology in its mature state to a new technology in its not yet mature state. And in fact, we know that new technology will keep improving. Look at cars. And I think that's the thing. So we compare the old technology in its mature state to the new one in its not mature state. We also are very aware of the jobs that are being lost, but we're not as aware of the jobs that are going to be built, so manufacturing and mechanics, and policemen who have to check speed and everything else. I think another thing too is we sort of need to venture into the unknown here. So if you look at automobiles, there were major issues with road deaths, especially climbing in the 40s and 50s. One of the most common accidents, by the way, at that time was getting impaled on your steering wheel. It's pretty gruesome, right? Quite a way to go. And so these engineers were trying to figure out, well, how do we make more padding on the dashboard? We'll make the steering wheel soft and it'll crumple in a way so when the person's flying around this car in an accident, they don't get brain damage and get impaled. And eventually, some engineers, and actually Robert McNamara at Ford at the time was big in this, he said, well, what if we just put a seatbelt so they weren't flying around the car to begin with? What do you mean? No one's going to wear that. It's uncomfortable. People are going to want to take that step. No way that's going to work. Well, yeah, now we all wear seatbelts and it's illegal, and we have someone in the back who'll probably let you know if you're not wearing one, and you need to figure that out. And so I think we need to some extent, it's scary, we need to go a little bit into the unknown. We need to prepare for and be ready to clamp down on risks. I don't personally think the right answer is to stop development because we're afraid of the risks. I'd be more comfortable to stop development and stay where we are today, but the world's moving, and it's not going to wait for us. So what are the risks created by AI? Here's some I'm worried about. Super viruses. Right now that most genomes can be deciphered and edited, that's a big risk. Someone can make a super virus that's super contagious and super deadly and spreads through the air. I'm afraid of that. Super hacking. So I have a really good friend at Harvard who did his PhD in cybersecurity. He's one of the world expert hackers. He actually did a stunt. He's Swedish. He did a public stunt where he hacked the phone of the king of Sweden and showed how we all need to be more safe, I guess. And so in his research, he's found that yes, AI can help cybersecurity experts be more secure, but it helps the hackers more than it helps the people trying to make things safe, unfortunately. So that's a big risk. Another thing, vulnerable systems, yes. So if someone, again, could hack in, or even if we just have vulnerable AI software that, again, we don't have guarantees on its performance, running our communication grid, running our power system, that's a problem. I actually personally think we should add some more analog controls in our power system, for instance, so we're more robust. There's another one. There's a rise of AI girlfriends and boyfriends out there. Some people are just withdrawing from the social scene, and it's a real problem. Depression's out there. It's easier to not engage, right? Why not go to that sycophantic AI girlfriend and you don't have to worry about getting rejected? That's a real problem. And then massive job loss is another concern of mine. So the horse-to-car transition happens slowly enough. I think some of the older people who are farriers could just kind of, keep doing it until they retired, and younger people coming in could be trained to be mechanics. They weren't going to go study farriers as much, and it worked out. What if in 5 months we'd gone from all horses to all cars? That would have been cataclysmic. And of course, we talk about reskilling and training people with old skills to do new things, but that's easier said than done. It costs something. Some people are willing to do it. I think we as a government need to be prepared to subsidize training. I even think something like taxing very powerful models, people running them to provide for people who are losing jobs. I don't think it's out of the question. I don't like taxes, I don't like big government, but we need to make sure that we're taking care of people and not letting technology cause massive harm. What about AI data centers? And this one and one more point, and then we'll open up for questions. But Nobles County is just south of us in Murray County. It's where Worthington, Minnesota is on I-90 over in southwest Minnesota. They've been trying to build a 1 gigawatt data center. 1 gigawatt. So that's like 500 of these big wind turbines, right? So it's a pretty large gas or nuclear power plant. That's how much power it's going to consume if they build it. And it's back and forth, they need to get the zoning permits. And just a few weeks ago, the Nobles County Zoning Board recommended to not approve the zoning change that we made for this AI data center. So it looks like they might not be able to build it. Well, that's probably got a question here.
AI doesn't work without a data center?
Oh, good question. Does AI work without a data center? You need some kind of computer to run those models.
Okay. So what is, how much data center capacity is correct? How much is too little, doesn't make it work right? How much is more than we need?
I think that's a very deep question. People are using these large language models all the time. I make several queries a day. They're being layered in now. Even a regular Google search, there'll be the AI version answer to your question. Right now, the free market's determining it. How much does it cost Google to give that result? How much more likely does it make you to use Google? How much can Google sell those ad slots for your search? And that's how they determine how much they want to use. I think we could say maybe the free market's not a good enough decider. One concern is, for me, we could build all these data centers and then models could get more efficient and we won't need them anyway. It's impossible.
What's the financial part of it? So Elon Musk, my partner, and I are going to build 80 acres worth of data center out here. How do we get paid?
Well, that's one thing that's not clear. I think that's a big issue with these data center companies. They are not being transparent. So, I mean, how would you get paid? I think most companies are building their own proprietary data centers. At some point, I would imagine we'll end up going the way that Amazon Web Services did, where there's a big company that has servers, and if you're a startup company, Joe Schmo startup company, you could rent off some server and run your models on it. I don't know which model is going to prevail in the long run. So yeah, it could be a company that runs the data center and people can rent space on it. It could be ChatGPT or OpenAI that runs that, could have their own private, probably some of both. I think the big concerns are, how are we doing on time, by the way, Phil?
We're about ready to open it up to some other folks to speak briefly and then open Q&A. So
Okay,
it's
what?
almost game.
Why don't I wrap up here then? I appreciate the engagement. We'll have some Q&A time. So my take on this is, okay, there's a few concerns. Number one, people talk about water. These things use a lot of water. My understanding from what I've read, they take in water once, they use it to cool, and that's not a big concern. But they use a ton of energy, and that's a huge concern for me, because if we raise energy prices, that affects every family as a progressive tax. I also think, like this one in Worthington, they have not said who's going to own it, how big it will be, how many jobs it will create, how long it's going to be there. People want answers to these questions before saying, yes, build a 200-acre data facility in my town. This is the last quick point I want to make. Does anyone know what game is being played here? Chicken. Two cars drive toward each other as fast as possible, and the one that dodges first loses. That's what we're playing right now. That's a more accurate set of passengers. I, of course, put the US in the car that's on top, because I think we're going to win. We could stop developing AI to avoid AGI with big risks, but if China keeps building it and gets killer AI drones first, or super hacking AI first, that's a massive, massive national security risk for us. So we can't stop building, but if we keep building, there's massive risk of harm like we just talked about too. I think it's the uncomfortable position we're in. I do think we need to keep building, but we need to build the energy generation, and we need to prepare for existential risks, and that actually needs some budgetary allocation. And actually just today, this morning, Donald Trump was going to sign an executive order limiting AI development. He decided not to because he doesn't want us to bear the risk of China getting ahead of us. So we must develop, but we need to prepare for risk at the same time. And that's all I have to say. So thank you so much for your time and attention, everyone.